Have you ever wondered how everyday items like jewelry, kitchen utensils, or even connectors inside your smartphone stay shiny, durable, and resistant to wear? Well, the answer lies in the process called electroplating. Electroplating is a technique that coats an object with a thin layer of metal using electricity. It works through electrolysis, where electric current drives a non-spontaneous chemical reaction, meaning this reaction will not take place unless it is driven by the continual input of energy from an external power source. Basically means it needs electricity to function. Both metals are placed into the same electrolyte solution and the object to be plated, the cathode, is connected to the negative terminal of the power source. The metal that will be used for plating, the anode, is connected to the positive terminal. When electricity flows, metal ions from the anode dissolves into the solution and then deposits onto the cathode, forming a thin, even layer of metal. But why is electroplating so important? Well, it provides several key benefits to society. Number one, it improves the product's durability by preventing rust and wear, which extends the product's lifespan for items like car parts and home appliances or your phone. Secondly, it enhances aesthetics. Metals like gold and silver are often used to give products a polished, high-end look. Another major advantage, which is its cost efficiency. Instead of using actual gold bars or silver bars because it's way too expensive, manufacturers can coat less expensive materials, for example, stainless steel, with a thin layer of valuable metals like gold and silver, reducing its cost while maintaining the desired properties, for example, its aesthetic appearance or conductivity. And finally, advanced electroplating techniques can also help industries optimize resources and reduce energy waste, making the process more sustainable and economically efficient. Of course, like any industrial process, electroplating comes with environmental and health concerns. One major issue is hazardous waste. Metals like chromium and cadmium can contaminate soil and water if not properly disposed of. And another major issue is water pollution, as wastewaters from electroplating may contain harmful chemicals that threaten aquatic ecosystem and human health. We also have to consider the fact that it may result to air pollution, since some electroplating operations with poor electroplating techniques can release toxic fumes which can endanger the workers in those workshops. And the process of electroplating requires a lot of electricity as this is a non-spontaneous chemical reaction which requires electricity for electroplating to happen, which if sourced from fossil fuels can contribute to a lot of greenhouse gas emissions and climate change. From a health and safety perspective, workers are at risk of chemical exposure for sure, which can lead to, skin irritations if they inhale too much of the poisonous gas, respiratory diseases, or long-term illnesses. There's also the risk of burns or injuries from handling strong acids and heavy metals. Because of these concerns, strict regulations and safety measures are extremely necessary to keep both the people and the environment protected. So how is electroplating used in real life? Well, it's actually used in a lot of cases. So let's use kitchen appliances, for example, like forks and spoons. Let's use spoons, right? So how electroplating works for a spoon is first we need electrolyte solution, which if we're gonna coat a spoon or fork with silver because of its conductivity, its resistance to corrosion, it's long lasting, and it's because it's very shiny, it's very visually appealing. Then we would need a silver bar into the electrolyte solution, and so the electrolyte solution would be silver nitrate, for example. And then we will connect the wire into the positive terminal because as the anode is being oxidized. Then we're going to connect the other wire, the negative terminal, into the cathode, which is stainless steel, spoon, whatever. And then we're going to turn on the electric current because this is a non-spontaneous reaction. It needs electric current to make sure the reaction happens. The silver bar is going to be oxidized. It's going to lose its electron. The electron's then going to enter the cathode, which is a stainless steel, the spoon. And then the ions of the silver bar is going to be released into the solution. And because of the negative charge on the cathode because of the electrons, the ions are going to be attracted to it, and then it goes to it and then forms this thin, shiny, visually appealing protective layer of silver metal. In the chemical formula for the anode, the metal that is being oxidized is silver, 2 silver ions plus 1 electron. And the cathode, the one that is being reduced, is going to be silver ions plus 1 electron, 2 silver metal, which is that thin layer of coating. Another example of how electroplating is used in real life is gold plating in electronics. There's actually gold isn't just used for jewelry; it's actually used in your mobile phone. And the reason why gold is used in your mobile phones because it is a very excellent conductor and resistor to corrosion. In this process, the base metal, like copper, is placed into a solution containing gold cyanide. Then electricity is going to be applied, and then a thin layer of gold forms on the surface. The process is going to be exactly the same as the spoon, where the anode, the gold bar, for example, is going to be oxidized. The electrons then going to go into cathode, the mobile phone parts, and then because of the negative charge, it's going to attract the gold ions, and then it's going to attach to it, forming this nice thin layer of gold. And the chemical equation at the anode where the gold is oxidized is solid gold plus 2 cyanide. The aqueous solution is going to turn into gold cyanide 2 minus plus 1 electron. And at the cathode where the gold is disposed onto the foam parts, gold cyanide 2 minus plus 1 electron is going to form solid gold plus 2 cyanide. The 2 cyanide aqueous is going to be left out because we only want the gold plating. This ensures that the connector remains efficient and long lasting, reducing the need for frequent replacements. But how does this all relate to electrochemistry? Well, electroplating is entirely based on the process of oxidation-reduction redox reaction where electrons transfer between substances. At the anode, the plating metal loses electrons. It's being oxidized, forming positive ions into the electrolyte that dissolves into solution. And the cathode, the negative electrode, is the object that's being plated. It undergoes reduction, which metal ions from the solution gains electron and deposits onto its surface. Let's take Me metal with copper. So oxidation at the anode, for example, as we want to coat Me with copper, the oxidization will happen at the anode, which is the copper bar. So the copper bar is going to be oxidized into copper 2 plus aqueous plus 2 electrons. And the reduction is at the cathode where the electron goes through the wire into the cathode, which is the Me, is going to attract the copper ions and it's going to form this thin layer of coating, which is copper 2 plus ions plus 2 electrons going to form into copper solid. This process wouldn't happen on its own as it requires an external power source to drive the reaction, making it a non-spontaneous redox reaction. So to sum it up, electroplating is an essential process that improves durability, appearance, and functionality in everyday products. It provides economic and societal benefits, but also comes with environmental and health concerns, which needs to be managed responsibly.